Hey, so can you hear me okay? Yeah. Okay. So yeah, I'm going to talk a little bit about large language models and using them for accessibility work. I'm Craig. I have ADHD. I'm also autistic, so I always say, depending on which side wins, the talk will either be really clinical or really erratic. We're a bit behind on time, so hopefully the ADHD will kick in and we'll get through it. But yeah, I used to work at DWP. I was the head of accessibility there for 3 years. I've worked at Elastic, if you've heard of Elasticsearch. I did some work there, and I currently work as a principal accessibility specialist for Technological, which is an accessibility consultancy that comes out of London. Before we start, the slides that I have that you'll see on the screen, they're a little bit wordy, and that's because they obviously include prompts and language responses from large language models. I'll read through all of the things, so if you can try and just refrain from trying to read them all while I'm talking. I know it's difficult. I do it straight away. It's as soon as the slide comes up, you start reading it. But yeah, I'll talk through it so you won't miss anything. But yeah, AI is everywhere. And the question, I suppose, is do we really need it? Like every single product just seems to be building AI into it for the sake of it, like literally everything. I mean, there's so many products now where there's a chatbot pops up and you can do all sorts of stuff that you don't need to do. I don't know if anyone attended AxeCon this year, but DQ showed this slide, which is, it's disappeared off the internet now. They got a bit of backlash for it. But they said that 100% of accessibility development testing and fixing can be done with zero specialized accessibility knowledge with DQ solutions. This was their vision for going forwards, and they have put a lot of time and effort, I think, into doing AI stuff behind the scenes, because they released their Axe Assistant a few months after this AxeCon talk, and we'll get into a little bit with Axe Assistant in a bit. But I suppose before I start talking about large language models and how you can use them or not use them for accessibility, we probably need to talk a little bit about how they work, because that will really help underpin some of the problems that I've kind of found. But basically, LLMs are given massive amounts of data, books, websites, articles. This is where a lot of copyright contention comes in. They're literally just given all this information, and then they kind of pull it apart and learn from it. And LLMs basically take all of this content and they break it into what they call tokens. And a token can be a word, it could be a piece of punctuation, it could be half a word, depending on how complex the word is. There's kind of an algorithm that works on it. You can't really know what is going to be a token and what's not, but the more complex the language, the more complex the content, the more tokens that it'll use up. And the pricing models of LLMs tends to go on how many tokens they process, so the more complex the thing that you're trying to do, the more expensive it becomes. LLMs then use probability on these tokens to form responses. So this is the thing that a lot of people don't realize, is that LLMs are basically just massive probability number crunching machines. They just are kind of looking at, given the current context and given the words that have come before, what is the highest probability of the word that's going to follow. So for example, it might say an elephant grasps tree branches using its, and then it's trying to work out what the next word should be. They use this thing called a surprisal score, which means that if it puts a word in, which it's really surprised to see there based on all of the knowledge that it's trained on, it'll have a higher surprisal score. So this is a really simplified example, but obviously an elephant grasps tree branches using its trunk would be a 0. I'm not surprised at all to see that word there. Hands, high probability that that is the wrong word, because none of the content that I've been trained on said that elephants had hands. So that's kind of how the surprisal score will work. If you're vague in your prompts, or if the thing that it's writing it doesn't know much about, it becomes more difficult. So if we had a sentence like people are often looking for, then it becomes a lot more difficult for the LLM to work out what the next word should be. So it might be love, it might be jobs, it might be elephants. Elephants is probably going to score higher on the surprisal score, because all of the data that it's been trained on, elephants probably doesn't follow that sentence very often. It's the same with code. So if you have a hidden level 1 tag and then the word accessibility, and then it's trying to work out what the next thing should be, the surprisal of seeing a closing H1 tag there would be very low. The surprisal of seeing a closing paragraph tag there would be very high, because all of the HTML code that it's been trained on says that you need to close a H1 with a H1 closing tag. So this is just kind of how, in the background, they're doing this surprisal score. And this is also how like loads of bias creeps into LLMs. So they have a problem of regurgitating information, which is, it is inherently biased because they've been trained on all of this human data, and all of the human data is biased. So then they're not surprised at all when all of this biased information comes back out. They're like, that sounds fine based on all the things that have been trained on. And this is how a lot of the things that we see where LLMs look like they've gone rogue, they haven't really went rogue. They've just been trained on data that is inherently bad, and then that comes back out. So some problems with LLMs, obviously I've just touched on one, but there are some real issues with these things. So they hallucinate. This is just a nicer way of saying that they tell you stuff which is not true. People stop short of saying that they lie all the time, because apparently in order to lie, you need to be conscious that you're doing it, and there's a manipulation there, and they're not sentient, that we know of. But yeah, they can't lie because they're not sentient, so they call them hallucinations. And I suppose it's a lot easier to market something that hallucinates than something that lies, so maybe that's why they've done it. But yeah, they do this all the time. They basically tell you stuff that's not true. They see things in pictures that aren't there. They will tell you very confidently the answer to something, and it's totally incorrect. Sometimes they quote things that, again, they'll quote somebody, and you're like, where was that quote from? And they're like, oh, that wasn't a thing. I mean, we were discussing earlier the Tony Blair quote, and it didn't even exist. It's like he never said it. So yeah, I just mentioned before, like they're often biased. They're trained using billions and billions of sentences that were written by humans. All of that historical biases. I mean, they're trained on historical data, like stuff that was written years ago. Times change, but when they're reading biblical scripts and all sorts of stuff, they're not going to have, I don't imagine they had very many accessibility and inclusion policies in those sorts of days and whatnot. So all of that bias and all of that ableist language and whatnot kind of creeps into the LLM's responses because that's what it's been trained on. And I think this is the thing as well, like I suppose the main thing to take away from all of this, to talk about the problems, is that they are just trained on to regurgitate whatever it is that you give them. So if you give them more bad examples than good examples, those things will always float to the top. And that becomes really apparent when you start doing accessibility stuff. LLMs don't know facts. Like, this surprises a lot of people because like when I ask ChatGPT stuff, it seems to know everything. But actually, they don't know any facts at all. They just know the relationships between tokens. So if you say the capital of France is, they'll put the word France and you'll go, oh, they really know that, they know what the capital of France is. They have no idea what France is. They have no idea what Paris is. They don't know that. All that they know is that every time they see the words, the capital of France is, the word Paris, 9 times out of 10 will follow. They're not consistent. They can't give you the same answer twice. So every time you ask them something, they're then generating what is the most probable word to come after this one. And there is some variability within that. If the word is the same score on the surprisal scale, if it's within a tolerance, there's some degree of randomization in there. So they can tell you roughly the same thing twice, but it's really unlikely that verbatim they will just tell you the same thing that they told you 2 or 3 days ago. And yeah, if the data is bad, then the response of that LLM will be bad. And this is really crucial for accessibility, and it's really crucial for, if you're asking it questions about things like accessibility law, or you're asking it questions about accessibility standards like the Web Content Accessibility Guidelines, the data isn't great. I'm just going to come and drink somewhere a little bit more accessible. Sorry, it's really loud. So the WebAIM survey, which they do every few years, estimates that 94.8% of the top 1 million websites have detectable WCAG 2.2 failures. Sorry, this isn't an estimate. This is what they did. So they threw Wave, which is an automated accessibility tool, at the top 1 million websites, and they found that 94.8 of them had detectable WCAG failures on them. And we know that them tools only find around 30% of the known issues. So realistically, there's probably a lot higher of the number of websites that were actually accessible. It's probably like 99%. But it just goes to show that, the top 1 million websites, 94% of them, it's not great. We're not doing very well in terms of making things accessible. And because 94.8% of the web is inaccessible, LLMs have been trained on far more bad examples than good. So when you're giving them billions and billions of lines of code, and you're giving them billions and billions of words on accessibility and inclusion, 94.8% of the web is trash. Therefore, 94.8% of the information that you fed an LLM is probably trash, and therefore it has no way whatsoever of regurgitating good information. So LLMs and accessibility, like testing them in the wild. So this is some of the stuff that I've found just by, I get really curious about stuff. I go down rabbit holes. I love technology, and I just I'm like, oh, what can this do? And I try and think of ways that I can break it. Or take it apart and put it back together again. This I like to do a lot of the time. But I've spent a lot of time just digging into this and trying to see, what things because if you ask it, if you've never used something like ChatGPT before, and you go on and you just go, oh, what can I ask it? And you ask it something. You tend to ask it general things quite early on, and it'll give you quite good responses because it's really good at general information. But as soon as you actually get into the nitty-gritty and you need it to do something really nuanced, that's where it falls apart. So I like to try and think up really nuanced sort of questions I can ask it, or examples I can give it, and just see how laughable its responses are, I suppose. So there is a caveat. You might have already worked out I'm a little bit biased. I use AI for all sorts of stuff, but I don't rely on it for anything. So yeah, my bias is when I'm trying to build these experiments, I am trying to find out if I can break it or if I can get a bad response from it. But if it does give a good response, I'll show you a few. I'm trying to weigh the talk up, so it's like, here's a bad example, but also here's a good one. Because sometimes they do give good examples, but most of the time they're not great. But yeah, all of the examples that I use are stuff that I've done in the past few months, so April till August this year. It's using various versions of the language models that were available at the time. They are always getting improved. They're always getting fed new information. They'll have a training date up to a certain point. So all of the information that an LLM knows will go up to a certain point, and every now and then they'll kind of move that goalpost and feed it more information so it does kind of learn more stuff. So that, I suppose the caveat is, like all of the examples I'm about to show you, I've went and done some of them again, and they come out a little bit better, so I've put those in. But hopefully, in time, if they keep iterating it, it will get better, and then this talk will become redundant. So one of the first things that I wanted to work out was, can they write text descriptions for images? So, we just heard before about how important text descriptions are. We know that if you're in PowerPoint and you put an image into your slide and it has a go at writing the alt text for you, it's pretty rubbish. But I was thinking, well, large language models, they're trained on language, they're trained to be coherent. How good of a job can they do when you give it some images? So I deliberately picked this image, which is tricky. It's a stock image, which I bought off Alamy. It's a transgender person, but the description does not give you their pronouns. So when you look at the image description on Alamy, it just says, a young African-American transgender smiling confidently at street. So that was the description of the image. It's not the best, but you can see they don't mention any pronouns in there whatsoever. So you have no idea what this person's pronouns are, and therefore we shouldn't just guess. Like if you misgender somebody, that can be really harmful. So if you don't know, you shouldn't have a go. But that's exactly what this LLM did. So this was Mini CPM version 5, which claims to have better image recognition capabilities than ChatGPT. And it basically described an African-American woman wearing earrings with a smile. She is standing she is standing outdoors in what looks like a town setting or a street with buildings behind her that are out of focus. So it's immediately said it's a woman, use the pronouns she and her, and we have no idea if that is the case. Meta Llama 3.2 Vision didn't do much better. So Meta, made by the people who made Facebook, described the image as two young black men standing together in front of a blurred background. So this is a typical example of hallucination. The image that we saw before, I didn't describe it properly, sorry, but yeah, in the image that we saw before, there was one single person standing in front of the street. And this is describing two people and then having a go at the gender as well, which is obviously not what we want. But this is what we would call hallucination. It's quite clearly something that just isn't there at all. I did this a few times and tried to give Meta more context, and every time it still saw that there was two people there. I have no idea what that was doing, but given the amount of harm that's caused by Facebook, I don't imagine that inclusion's kind of top of their list when they're trying to do this stuff. But yeah, Llama and Mini CPM, which I've just shown the other example of, these are LLMs you can run locally on your machine, whereas the likes of ChatGPT are cloud-based services. But with these, you can run them on your own computer at home if you like to cook your CPU, and you can get them to do all sorts of stuff. So you can write a script that batch runs against thousands of images and just have them, I want captions for all of these images, and just run through the script. But obviously, if it's doing stuff like this, you don't want to then just put them out into the wild. So if you are going to use these for any of this stuff, we need like a human AI collaboration sort of situation, because if you were to put this out on, a blatant hallucination out in your alt text, that's going to be really embarrassing for you. ChatGPT did pretty good. It said, a smiling person with short hair, a nose ring, and earrings wears a black t-shirt outdoors in a sunny urban setting with palm trees and blurred buildings in the background. So ChatGPT did pretty good. They used the word person rather than having a go at their pronouns, and it did a better job than me describing the image. Sorry about that. But yeah, ChatGPT was pretty good in this setting. This next image is an image that I took in Las Vegas. I had to go to Las Vegas for work. I hated it. I described it as a toddler's built a city in an oven. It was the only way I could describe it. But yeah, I had to go there for work. I didn't particularly enjoy it, but I had to wander around, took some pictures. And this is a picture of a replica of the Statue of Liberty that they have. It's in front of the New York Hotel in Las Vegas. There's a big roller coaster there. But the reason why I gave this to the LLMs was that I want to see if they can tell if this is a replica or not. The only thing that really gives it away is obviously there's a hotel and a roller coaster in the background, but other than that, it looks pretty much like the Statue of Liberty. And Google Gemini could not. So it described the image as a tourist snapshot of the Statue of Liberty, taken from below, showing its full figure and torch against a clear blue sky, highlighting the monument's scale and iconic presence. Which would be a pretty good example if it was right in one of the Statue of Liberty, but the one that's in Vegas is about half the size, so it doesn't really highlight its scale anyway. But yeah, I had no idea that it was the wrong place. It described essentially the wrong thing, and in the wrong, given the context, if this was a travel website about Las Vegas, it would be a bit alarming as to why is there a photograph of the Statue of Liberty in there when it's on the wrong side of the country. ChatGPT did okay on this one. It described it as a large green Statue of Liberty replica, stands on a stone pedestal against a clear blue sky. A bird is perched on the statue's torch. A red roller coaster and buildings are visible in the background. So it did all right. Like, it recognized it was a replica. It recognized it was on a stone pedestal. It saw the roller coaster, but there was no bird on the torch. But is it a hallucination or is it an honest mistake? Because I guess the flame does look a little bit like the back end of a pigeon. So maybe it wasn't a hallucination, it was just an honest mistake, but again, it's just another thing where it nearly got it, but it wasn't quite there. Anthropic Claude did quite well with this one. It described a replica of the Statue of Liberty, stands outside the New York Hotel in Las Vegas with a red roller coaster visible behind it. So that didn't really hallucinate, didn't really get anything particularly wrong. It did all right. But I think what's interesting about this as well is it shows you where LLMs kind of cut corners, because Google failed completely and thought that it was the real Statue of Liberty. But Google actually has access to all of the images on the internet, and it can actually go and look things up. So Google could technically have cheated and just went and looked, for similar images. It could have very easily worked out what that was. But again, it's that thing of it'll only use the number of tokens. It'll use the minimum amount of tokens that it can unless you provide it with more context, because tokens are expensive. So the more things you try and do and the more you go for accuracy, the more expensive it becomes. I mean, there was a running joke a while back because of the CEO of OpenAI who wrote ChatGPT. They was saying it costs millions of pounds for people using please and thank you with ChatGPT. Because like you'll ask it to do something, and you're like, oh, please do this thing, thank you. And that's like 3 more tokens that it has to process. And obviously, if like millions of people are doing that, there's just loads of tokens of please and thank you getting processed that aren't needed, and it costs them loads of money. So they will always take the shortcut unless you give it context. And I think in this case, obviously, Google probably has access to the image of the transgender person. You know, it can quite easily reverse Google image that and find out the context. It could have found out the Statue of Liberty example, but unless you ask it to, it just won't. It'll go for the cheapest option. And the next one is, can LLMs advise on WCAG success criteria? So the Web Content Accessibility Guidelines, you know, a lot of us who are doing accessibility work, we work with this standard. If you've not come across it before, it's a way of measuring how accessible a website is based on a whole bunch of criteria. And it's really, the documentation is really complex. The standard itself is really complex. So a lot of people who are doing audits are always kind of looking at the different criteria, and they're like, oh, does it fail this one? Does it fail that one? WCAG is notoriously difficult to understand. Like, again, there's a running joke, like WCAG itself isn't really that accessible. So I guess this is where I found some of this is where I thought it would be the most interesting use of LLMs. I was like, if they can understand WCAG, then maybe they can interpret it, and it can help people who are trying to get into WCAG to understand it better. So I thought that was a good use case for it, so I thought I'd give it a go. So one of the things with WCAG that's a pain and makes it difficult to understand is that you can have the same problem present itself in the same way, but depending on which HTML element it is on, might depend on which criteria that it fails on. So on the surface, it looks like the exact same problem, and you're like, I've seen this before, I know which criteria this is, and it's not, because for some reason, links and buttons and whatnot get assessed slightly differently. So in this example, I basically wrote a link. So this is a bunch of HTML code. You don't really need to understand it, but the A tag at the top is an anchor, it's a link. The button at the bottom is obviously a button. And basically the link is made up entirely of an image, which does not have an alt attribute, which means it doesn't have any text, it doesn't have a text description attached to it. So the link essentially has no accessible content. And the button is using an SVG, and that doesn't have any accessible name either. So basically, both this button and this link, if you were using a screen reader, would just read out link or button, but you'd have no idea what it was. If you could see it, obviously you could see the icon, you could see the image, and it would be fine. But for screen reader users, it's the exact same problem, but it's on 2 different elements. So the link would fail 1.1.1 non-text content, which means the image doesn't have any text content associated with it. It would also fail 2.4.4 link purpose and context, which means the link doesn't have an accurate description for where it's described, and it's going within the context of the surrounding page. And it would fail 2.4.9 link purpose, link only, which means that the link needs to be descriptive just by the link text alone. So things which commonly fail this is like, you know, when you see like text that says read more or click here, they're examples of things that would fail link purpose in context or link only. And then for the button, it would fail 4.1.2 name role value, which basically means this element does not have an accessible name attached to it for screen readers and voice recognition software and those sorts of things. So again, exact same problem, but different criteria. So I basically said to the LLMs, I was like, I've got a button and a link, neither which appear to have an accessible name. Can you identify the problem, and can you tell me exactly which WCAG 2.2 criteria this would fail? And then I gave it the code, and I gave it this prompt, and I was like, what will it give me back? So this is DQ Axe Assistant, and it was like, for the link, it would fail 1.1.1 non-text content. And for the button, it would fail 4.1.2 name role value, but it didn't mention link purpose in context or link purpose link only. So it kind of got, I suppose, 50% of them correct. OpenAI ChatGPT 5 told me the same thing. It was like it would fail 1.1.1 non-text content for the link and 4.1.2 name role value for the button. But then it also said the link would fail 4.1.2 name role value as well. And this isn't necessarily incorrect. Like, I've seen some auditors who would fail it against that. It's basically an interactive element that doesn't have an accessible name, but normally, because there's separate criteria for links, we would fail it on the link one. And you could add name role value in there as well, but it's just going to add noise to the report. It's probably a moot point because it's covered by the other things. So it's not necessarily incorrect, but some auditors would include it, some auditors wouldn't, which again highlights the problem of having a standard that's a little bit subjective. But again, it got 50% of them correct. But 50% accuracy is not good enough for WCAG conformance. So if you're working to a standard and you need to audit something to that standard and you need to say whether it passes or fails, like if you know what you're doing 50% of the time, you're not going to be a very good auditor. So it doesn't do that well with these kind of problems, and I do find the more nuanced that they are, the more challenge that it has to try and work out what the correct criteria is. If you say this image doesn't have alt text, 9 times out of 10 it'll get it correct every time. But when you start getting into some of the more, the ones where even the W3C, if you go on the GitHub account of W3C and you look at the WCAG documentation and you look at the issues that people are raising with the WCAG documentation, 9 times out of 10 the W3C can't even agree between them what the interpretation of WCAG is. So I suppose it's inevitable that the LLM isn't going to do a very good job either. And they do update the documentation from time to time. So they might agree, yes, this is unclear. They change the wording in WCAG to make it more clear. But the LLMs have a cutoff date for their training material, so they don't necessarily get access to the changes. So when you're asking them things, their knowledge on WCAG might be out of date to where it's currently at, because they do patch it quite frequently, just updating the content. The next thing that I wanted to know was, can LLMs restructure content to fix accessibility issues? So they're supposed to know content and they're supposed to know context. This is what LLMs are apparently, well, where they're supposed to shine. So what I wanted to do was kind of work out, well, does it know if I have a whole bunch of headings, what levels those headings should be based on the surrounding content and those sorts of things. So I took a big document. This is the accessibility strategy for GDS from gov.uk. So you basically just go to the website, they've got their whole strategy mapped out. There's 45 headings on that page, and there's a lot of content. So I was like, okay, well, what I'll do is I'll take all of this content, I'll give it to the LLM, but what I'll do beforehand is I'll jumble up all the headings. So this is just the first 10 headings. On the screen, there's H1 down to H4, and there's 10 different headings. It kind of starts with accessibility strategy. It goes down to prioritizing accessibility concerns. Then it's got concern types, theoretical concerns, evidence concerns, and it kind of goes, you know, H1, H2, H3, H4. So all I basically did was take all of the headings so I gave the LLM the whole HTML content. It wasn't just the content alone. And I took all of the headings and I jumbled them up. So the H1 became a H3, H2 was a H5, H3, the third heading down, was already a H3, and it stayed a H3. I don't know if I meant to do that, or it got one for free, basically. I don't know if it was on purpose or not. But I jumbled all the headings up, and then I passed all of the content into the LLM, and I was like, can you tell me, you know, from an accessibility point of view, is this content accessible, and kind of what's wrong with it? And then they started to kind of pitch responses back. So it's underneath the captions, which is, this one is ChatGPT, this one. Sorry, I put it at the top of the slide this time and it's been cut off. But yeah, this is ChatGPT's response. So ChatGPT was like, it's got the heading 1 right, got the heading 2 right. The heading 3 was already right, so I don't know if I can give it that one. Maybe I can. Maybe I can be really harsh and say it didn't get it, but it was correct anyway. Everything from that H3 downwards, it got wrong. And what happened was basically it thought that what should have been a H4, it marked as a H3. And then it had a knock-on effect to the rest of the content, which it just couldn't recover from. So because it had grouped the heading wrong, it was then trying to group all the information into the next heading, incorrect to the one above it, and there was no way for it to recover because all of the previous context that it has was incorrect. So it only got the first 3 right, and then the next 42 of them wrong. And this is Google Gemini, and this did the same thing. So this one managed to get a few more right. It got the first 5 right. But then once it got to the 6th heading, it got one of them wrong, and the same thing happened. They just had this chain reaction right through the rest of the content where it couldn't recover from it, and all of the preceding headings were wrong. So if you wanted this to restructure your content, I don't know how much time it would have saved you, because the first 5 headings out of 45 of them isn't really a great return on investment, but you'd still have to go through and kind of fix them. I think, again, this is another one which highlights Google's, in ChatGPT as well. These have access to the internet. Google has access pretty much to every single, it indexes websites, that's what it does. So, I mean, Google could have totally cheated and just went and looked up the correct heading structure because it should have known this content. But again, unless you ask it to do that stuff, it isn't going to do it. The next thing that I was trying to work out was, I'm just checking how we are for time. The next thing I was trying to work out was, can LLMs find readability issues which aren't to do with the reading level? So most of the time when you talk about accessibility issues to do with reading, they will talk about reading scores, they will talk about like how to formulate sentences in a certain way so that they meet a reading age of a 9-year-old or whatever. But one of the things that we see quite frequently, which isn't necessarily, it's not a WCAG failure, so it doesn't get audited, is that people write things in block capitals a lot of the time. And when you write things in block capitals, people who are dyslexic, for example, really struggle to read it because there's no word shape. All of the words just look like big bricks. So when we write things in block capitals, a lot of the time, it's an accessibility barrier, but it doesn't get picked up because it's not covered by WCAG and those sorts of things. And what I wanted to do was I wanted to know whether LLMs would be able to notice this. I did have a theory going into it that they probably normalize the data that you put in. So in sort of development terms, if you normalize something, you might take all of those capitals and then turn it into lowercase letters before you process it. Or you might, put it into sentence case or some kind of take all of the symbols and emojis and those sorts of things out. So I had a feeling that ChatGPT and Google and whatnot would do some kind of normalization, which means that they wouldn't even see the capitals in the first place. So maybe it was a bias experiment going in, but that's the hunch that I had. So this text as well, that's all in capitals, reads, the European Accessibility Act, EAA, is a piece of legislation designed to improve the accessibility of products and services across the European Union. It aims to remove barriers for people with disabilities by requiring companies make digital products like websites, mobile apps, ebooks, ATMs, and online shops accessible to all users. So I fed that in ChatGPT. This is ChatGPT 5. I've just realized that on the slide it says it was ChatGPT 4, but it was actually ChatGPT 5. Originally, ChatGPT 5 didn't tell me about the capitals. It didn't know about them. It just responded with a bunch of stuff. But then when ChatGPT 5 came out recently, I was like, I'll try it again and see if it's any better. And it was. So ChatGPT 5 said, all caps reduces legibility and it feels shouty. Use sentence case, 2 long sentences, 55 to 60 words in total. Aim for shorter sentences. Passive, wordy phrasing is a piece of legislation designed to. So it did find the capitals, but ChatGPT 4 didn't, which I guess is an example of how these things are continuously improving. And if you ask it the same question, 2 weeks apart, it might give you a totally different answer. Google Gemini 2.5 Flash is a newer version to the one that I was using for the image recognition and that sort of thing. So I thought I'll give Google another go. We'll see if that can figure it out. And Google 2.5 did better. So 2.0 didn't find the capitals, but 2.5 did. So it says the use of caps is an unusual choice, and it can sometimes be perceived as shouting, but it does make the text stand out. However, for a longer piece of writing, all caps can decrease readability. In this short paragraph, it doesn't pose a significant problem. It did find the capitals. I disagree with the fact that it doesn't pose a problem, but that wasn't a short paragraph. That's multiple lines of text that just looks like a big brick on the page. I definitely think there's people with dyslexia who would struggle to read that. So I don't agree with the advice, but it did find the capitals. This is DQ Axe Assistant with the same problem. It didn't find the capitals. So I tried DQ Axe Assistant again recently, didn't find it. It basically just talks about text structure. It says the text is presented in a single block without any headings or subheadings. The length and complexity, the sentences are quite long and complex, and there's a lack of lists. The points related to digital products, for example, websites, mobile apps, ebooks, ATMs, and online shops, could be formatted as a bulleted list or numbered list. And so it didn't find the capitals. Its advice isn't bad, but what it did was it gave me an example of how I should have rewritten it, and what it did was actually quite alarming. So the original content finished, and it was saying, by requiring companies make digital products like websites, mobile apps, ebooks, ATMs, and online shops accessible to all users. What DQ Access Assistant did was it took all of my content, it rewrote it for us, didn't ask it to, but that's what it decided it was going to do. And what it actually did was it put these into a bulleted list, but it actually missed the word accessibility out and it completely changed the context of the sentence. So what it said was companies are required to make digital products such as websites, mobile apps, ebooks, ATMs, and online shops. So it actually missed the point that it was to make these things accessible, and it kind of implied that in order to meet the European Accessibility Act, you need to go and manufacture ATMs if you're a bookshop. Which obviously, you know, if you're trying to use something like DQ Access Assistant for legal advice or for, you know, if you're advising policymakers and this sorts of thing, telling them this is going to massively change the strategy of your organization if people fall for it. The next one was, can LLMs fix accessibility issues in HTML markup? Again, with, you know, there's a lot of like vibe coding now. I don't know if you've seen it, where people basically just, there's like, you can hook it up to a code editor that's got an AI in it, and you can just talk to it, and it'll just build an application for you. And it works to a point, but if you actually understand the code and you're reading it, you'll see like a lot of it makes no sense, and loads of it's redundant. It'll write a load of code in, but then it's not actually getting used. It's a bit weird. But if you've got no coding experience, you can build a better app than you could if you were doing it by yourself. So I wanted to see how well can it code for accessibility. So again, I gave it some HTML. So this is I haven't put all the HTML here because it was a whole page, but basically it was a HTML. The HTML page, there was a language attribute on the HTML tag, which tells screen readers and assistive technologies that this whole page is in English. It's got a lang equals en. Language is English on this page, and then everything else that follows this is also English. I put the H1 outside of the main body of the content. So anybody who's navigating with a screen reader, they can jump around with landmarks. So you might decide you just want to go straight to the main content of the page. You don't want to read the navigation or the header or whatever. I just want to go straight to the main content. But because the H1 is outside that tag, you'd essentially jump past it, and you'd just be starting the content with no heading to kind of line up what it was that you were going to look at. And the other thing that I've done is I've put on the paragraph tag, I've put the direction as right to left, but then I've also put language equals en. So I'm basically saying the paragraph that says, can you tell? Obviously, the H1 says, what is wrong with this code? The P tag, the paragraph tag, says, can you tell? And what I've essentially done is put the language attribute on the paragraph tag, which is redundant because it's already on the HTML at the top that tells them the whole page is in English, so there's no need to keep repeating it. But the direction right to left implies that the English is read from right to left, when obviously we all know it's read left to right. So right to left is more for like Arabic languages and those sorts of things. So then I was like, I fed this into the LLMs, and I was trying to find out, can you find the problem and can you fix it for us? This is the slide that I should have had up that explained everything. Sorry I didn't skip through it, but yeah, basically the same thing that I've just said. Headings outside the main tag, English is not right to left, there's an unnecessary language attribute. So this was the response from DQ Access Assistant. It says the language attribute is correctly applied to the P tag, which is good. It's not. And then it said, however, if the text is in English, it should not have the direction right to left attribute. Change the direction right to left attribute in the P tag to left to right if the text is in English. So it got the point that it shouldn't have the right to left attribute, but the two things that it told me to do was to basically just change right to left to right. It didn't have the foresight to know actually these attributes shouldn't be used and you've used them incorrectly. So based on Access Assistant's solution, I should have left the redundant language attribute there. I should have changed the language to left to right, when actually I should have just removed those things altogether. So it's not necessarily that solution wouldn't have worked. It's that it's unnecessary. Like, if you set the language to English on the HTML tag, it's implicit that the language on the paragraph tag is in English. It's also implicit that the language is left to right because that's the default. So by adding things in which aren't needed, you're creating bloat in your code base, but then you're also creating situations where bugs might arise. Like, we know very well how screen readers react to a paragraph tag. we don't necessarily always know how they're going to react to overriding things which are implicit anyway, because sometimes bugs can be thrown up. So there's a lot of research that suggests a p tag's fine. There's not that much research that suggests adding things which are implicit as explicit attributes, whether it breaks on various screen readers. So some final thoughts, and just kind of to wrap this up. Again, I think we're a little bit over on time, so I'll rattle through it. But LLMs, in my opinion, this is just my opinion, I suppose. You can derive your own conclusions from this, but in my opinion, they're not ready to do accessibility. They will confidently tell you the wrong information and the wrong things to fix accessibility problems with absolute confidence. I mean, at this point, you know, they're probably not much better than the mediocre middle-aged white dude in tech, basically, where you ask them and they don't really know the answer, but they're just going to tell you anyway because that's what they do. Inaccuracy decreases with complexity, and accessibility is complex. It's really nuanced, it's really specific, and there's just not a lot of good data on it because 94.8% of the web is inaccessible. So all of these LLMs have been trained on all of this data, and they've been trained on all of this code, and it's all trash, and therefore when they tell you code fixes, they're all trash, but it thinks that they're right, and they'll tell you that they're right. And LLM agents are not the solution either. I haven't had time to really go into agents, but these basically chain multiple responses in order for them to be able to do things. So when we were talking before about vibe coding, where you're like, I want to write an application for an iOS, like for Apple devices or whatever, you can have it build an application, and an LLM agent will take what you've asked it to do, and it'll stack responses together, and it might chain 10 to 20 of them at a time in order to be able to do more complex things. Otherwise, you'd just be having like a back and forth every 2 minutes, like paragraph by paragraph, having to build a thing. So LLM agents are becoming really popular now, where you could have them go through your emails and write a whole bunch of responses, and it will just chain together these commands. But when you chain multiple incorrect answers together, it compounds a problem. So this is a chart that's on the screen. There's 3 lines that are kind of running down it, which show that the accuracy of the responses that you get from an LLM drop off the more steps that you put in. And this is, the credit to this goes to a guy called Utkarsh Kunwat, who has built multiple LLM agents, and he wrote this whole article basically on why he is not backing them for the future. He's built 12 of them, and he says they aren't going to really go beyond where they're at. And it's not that it's an engineering problem, it's a mathematical problem. So you cannot make something that has 100% accuracy. So if we estimate that an LLM can respond with 99% accuracy, when you do that over 20 steps, that 99% accuracy drops to around 82%, because if you get one little mistake, like we saw with the headings, it has a knock-on effect to everything else in the process. Realistically, we know that LLMs are nowhere near 99% accurate. Even if we were like, you know, we gave them 95% accuracy, even that's a little bit, you know, it's a little bit generous, I think. But if we gave them 95% accuracy over 20 steps, you've dropped to 36% accuracy. So if you're having this write production level code, or you're having it write things that you know need to be accessible, you need 100% accuracy, or at least, you know, 99, and 36% just isn't going to cut it. So if you're using LLMs and you're stacking all of these things together, the more that you ask it to do and the more complexity you add, the more likely it is to get it wrong. And then you also have a cost problem. So again, this is from the same guy, but the economics basically just doesn't scale. So this is the token economics, I suppose, of an LLM. If you have like up to 50 turns, which means like a back and forth conversation with an LLM, you're paying around $2.5 for that exchange by the time you stack together all of the tokens that it's processed. So 50 turns, $2.5, that's pretty reasonable. If you go up to 100 turns, which is double the amount, the cost is over $100. So it's like exponential in the amount that it costs when you get more complex. And the reason is that the LLMs, if you're asking it to do more complex things, or if you're asking an agent to stack things together, the first time you ask it to do something, it only has the context of the prompt that you've given it. But once you get up to 50 turns, it has all of the context of the previous 50 things that you have said between you. And once you get to like 100, Like every single thing that it's doing, it has to try and remember all of the previous context. Otherwise, it'll start telling you things which you told it at the start, and then you get frustrated at it. So the more complex it is, the more stuff it has to remember, the more exponential the cost is, because it gets beyond what they're kind of capable of. And this is what he's talking about when he's saying that it's not an engineering problem, it's just the mathematical nature, I suppose, of how these things work. And I guess the question is, right, if LLMs can really do accessibility, why aren't they accessible? This one I find really amusing. Like, none of these LLM interfaces actually are accessible. Like, if you go into the code and you look through them, they all make really silly mistakes. Steve Faulkner, who I work with, has written a blog post called AI Affluential. He's basically done a little mini audit on ChatGPT, and even things like the prompt box, it doesn't have a label attached to it. It's got no accessible name. It's like the main driver of using ChatGPT is that prompt box, and it's not accessible. So I suppose we have to ask ourselves the question, right, is if these things really could do accessibility, why don't they just have them build their own interface and everything would be perfect? It's just a red flag, I guess, for me. It's a highlight to the fact that either they don't care or these things aren't good enough. And Anthropic Claude has released a VPAT, which is a voluntary kind of accessibility statement that you can use. So like if you're selling software to a company, they might ask for a VPAT, which basically shows whether you meet WCAG or what things you fail against and whatnot. Anthropic Claude have actually released one, which is quite cool, because none of these other companies have. But then when you go to read it, you have to request permission to it. I did, I got denied. They said I couldn't read it. But if you do get to read it, so I do know somebody that got approved, but then they had to sign an NDA. So it was like, you can read it, but you have to sign a non-disclosure agreement, which probably means it's not accessible, if we're being honest. I mean, if you were accessible, would you really put it under lock and key? Like, they're signing an NDA because it's trash, basically, and they know that it's trash. There are no shortcuts to making things accessible, and unfortunately, the promises made by AI companies just don't live up to the hype. All of these things that they say they can do, when you dig under the surface and you try and design experiments and you try and see what they can actually do, most of them can't do what they say they can do. Some of them you get like the odd response where you go, oh, actually that was pretty good. And then in the following one, they're like, there's a pigeon on top of that torch. And you're like, no, there's not. I've written a more in-depth blog post about the image description. It includes the 2 examples in this talk. It also includes 2 others. It's on the Technological blog if you want to read that. But it just kind of talks a little bit more about the process that I did, and it talks a little bit more. There's responses from like 5 different LLMs, and then I gave them more context, and you can kind of compare how well they did. If that's your bag, you can read that. And I've also wrote a blog post on my blog, which is craigabbott.co.uk, which is around the first impressions with DQ Axe Assistant, again, which includes some of the things that I've talked about, includes some more things, and it's sometimes just, if you're into LLMs or you want to learn more about them, it can maybe help you to form some of the experiments that you can do to see if they're going to work for what it is that you're trying to use them for. But that's everything from me, and thanks for listening to me ramble.
Hi. My question is, a lot of this presentation, this talk has been kind of looking at, are large language models a reliable thing for doing things like generating descriptions of images, etc. How do you feel about the suggestion that is maybe but something, even if it's not 100% reliable, even if it sometimes misguesses a number of people or something like that, is still better than not having anything at all? Because I think that quite often that is actually the position that a lot of organizations are in, is that they just won't do image descriptions, and actually having an LLM give them a substandard one is arguably better than having nothing.
Yeah, it's a really good point. And so Leonie Watson, who I work with at Technological, Leonie's blind, uses a screen reader, and she said the same thing. She was like, it's better to have something than not to have anything. So I suppose, there's a heavy caveat with, as much as I'm biased against LLMs and as much as this talk has been like, oh, they're rubbish. they are better than not doing it at all. If this is all that you have budget for, this is all that you have time for, doing something is, and I think that's with accessibility in general, like everyone thinks that you need to be compliant and you need to, everything needs to be perfect. And I think it just needs to be better than it was yesterday. And I think this is no different. I suppose if you have no idea about WCAG at all, 50% accuracy on your audit is better than 0% accuracy. So I think, yeah, there is a caveat there. As much as I'm standing here saying don't use these things because you should, do it yourself and it'll be better. Like if you don't have them skills, then it's or you don't have the time or you don't have the budget for whatever it is that you're doing, then yeah, I mean these are definitely going to be better than doing nothing. I suppose it's just with a warning that human collaboration AI thing, like check it and make sure that it hasn't just spouted something that's absolute nonsense if you can. But yeah, it's a really good point, and yeah, thanks for raising it.
Thanks again, Craig.
Thank you.